Hello, my dear students. Now we'll resume the part that we stopped at in the last video about differentiating displacement with respect to time to find the velocity. And this is the last question about this issue, and then we'll go forward with acceleration. So let's read this question. A particle moves forward and backwards along a straight line. The displacement of the particle s in meters from its initial position O is given by s equals, and here is a formula, which is s as a function of time, and time is less than 4 seconds and greater than 0 seconds, where t is the time for which the particle has been traveling. Part A, show that the particle starts moving along the line in the positive direction. As we know in math, every word has a meaning. Starts moving means you will substitute t equals 0. Positive direction, you have to show that velocity will be positive, because if velocity is negative, then you are going backwards. So now part A, let's go. Here we have to find velocity from the displacement. The derivative of the displacement, which is power goes down, increases by 1. Power goes down, increases by 1. So it is negative 2.4 t cubed plus 7.2 t squared plus 2.4. And now we'll substitute at t equals 0. Velocity will be 0 plus 0 plus 0, no, plus 2.4. So velocity will be positive 2.4, which is greater than 0. And then you have to write your conclusion to gain the accuracy mark. Therefore, use the same sentence required, that the particle starts moving along the line in the positive direction. This is the meaning of starts moving in the positive direction. Now part B. In part B, the particle comes to instantaneous rest at point A. What does this mean, instantaneous rest at point A? It means velocity equals 0 at point A, and returns to pass through O and continues to point B, where the distance OB is the same as the distance OA. So let's draw a sketch for the motion here. Here's the start, which is O. It goes forward, then backward. Here is the arrow. Here's point A. At point A, velocity equals 0. As we said before, when turning to get back, as making a U-turn, for example, you have to make, even when driving your car, you have to make an instantaneous stop. And here is point B. And the distance from O, B is equal to, the displacement from O to B is equal to displacement from O to A. Okay, then how to find the displacement from O to A? Let's read again. The particle comes to instantaneous rest at point A. It returns to pass through O and continues to point B, where the distance OB is the same as the distance OA. What does he want? He wants us to find the speed of the particle when it is at B. So your target is to find velocity at B. Let's make the steps of our work. The idea is, after finding the velocity, after differentiating the displacement to find velocity, here we have it already done. The velocity is at A, velocity equals 0. When you equate velocity equals 0, this is an equation. You should solve. And when you solve, you will find t. But unfortunately, we cannot solve it manually. We cannot solve it in the normal methods by factorizing, nor by quadratic formula, because simply it's not quadratic, it's cubic, as you see. So that's why he wrote a clue in the question. Let's read this clue. you will need an equation solver for this question. But take care, you will not be allowed to use this equation solver in any exam. This is only allowed just to practice our work, but not in exams, of course. So when we solve it, we will get T. This is the first step. When you get T, go and substitute for this T in S to find S at A. Okay? S at A, which is, displacement OA. And then equate, because OB is the same like OA. When you get OB as a displacement, now you will substitute displacement to get T. We need to find T at B. When you find T at B, the next step is you will substitute it in velocity to find velocity at B. Let's say it again. We have already an expression for velocity in terms of T, which is this cubic formula, this cubic expression we can see now. And if you just substitute velocity equals 0, it will give you velocity, it will give you time when it reaches A. Then you use time when you reach A to find the displacement from O to A. But the displacement from O to B is the same like O to A. So you just equate and substitute displacement from O to B with the same value you will get. But take care, from O to B, of course, it will be negative, not positive. And this is an equation. You will solve it to find T. When you find the time at B, you will simply substitute the time at B in the formula of the velocity to find the velocity at B, and let's go. So now, this is how to solve. We'll say at A, velocity equals 0. He said this information. So now, negative 2.4 T cubed plus 7.2 T squared plus 2.4. When you equate it to 0 and use the equation solver, you will get only one value, T equals 1 second. So it means at A, the time will be 1 second, but we need to find the displacement at A. Okay, let's go. How to substitute now displacement at A, which it is OA, is negative 0.6 brackets power 4 plus 2.4 brackets power 3 minus 3.6 brackets power 2 plus 2.4 brackets. And in all these brackets, we substitute for the T as 1 second. And SA will be, after calculation, will be 0.6. Therefore, OB will be negative 0.6 meters. Why negative? Because as you know, it is in opposite direction. Now, when we equate S to negative 0.6, there will be one unknown, which is T. Here is the mistake, minus 7.2 T plus 2.4. Now substitute in S, because S now is negative 0.6, and this is at B. Negative 0.6 is equal to substituting the displacement to find, where is the displacement? Here it is. To find T. Negative 0.6 T power of 4 plus 2.4 T cubed minus 3.6 T squared plus 2.4 T. When you solve using the equation solver, you will get T equals 1 plus 4th root of 2 seconds. By the way, our calculators, our normal calculators, cannot solve an equation of power 4, but we can, of 4th degree, but we can solve of 3 of 3rd degree as cubic equation. I'm speaking about this one. This one, we can use mode 5, 4. It simply solves cubic equations. So after getting the time, we said, we now, after getting the time at B, go and substitute in the velocity to get the velocity at B. How to get the velocity? Here it is. Velocity at B is substitute in this one, which is negative 2.4 brackets, make big brackets, cubed plus 7.2 big brackets squared minus 7.2 brackets plus 2.4. And we substitute in the brackets 1 plus 4th root of 2. 1 plus 4th root of 2. Because thirds are exact. Thirds are exact. And fractions are exact. And pi is exact. We have some specific items, we use them as exact answers. Then when you find the velocity, it will be negative 4.04 seconds, and we're done. Da-da-da. Now let's start with acceleration. Acceleration is the first derivative of the velocity with respect to time. It means it is the second derivative of displacement with respect to time. Don't say d squared, say d2s by dt2. d2s by dt2. So here is just a reminder for some graphs about acceleration and deceleration. What is the meaning of acceleration? When you accelerate, when you're driving your car, when you grow up, when you accelerate, when you're driving your car, you will find that you're here, listen, it is, this is acceleration. When you decelerate, you just apply brakes and let's listen, it is. So acceleration is increasing velocity with respect to time, and deceleration is decreasing velocity with respect to time. The gradient of the curve, all these curves, as you see, they are velocity versus time. All of them velocity versus time. For the first curve, the curve is, how can I know that velocity increases? You'd simply watch the y-axis, x-axis and y-axis. In all these cases, it is acceleration because velocity increases with respect to time. But how to know that acceleration increases or decreases? If you take your ruler and imagine that you're drawing a tangent. Tangent is almost horizontal at the beginning, then it becomes steeper, 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 steeper. This is the same thing. In the second one, tangent is almost horizontal, means acceleration is getting, it's increasing, 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 because the gradient of the tangent of the curve is getting steeper and steeper. On the contrary, here in this case, we start as a steep gradient, and then it starts to have less steepness in those two cases, third and fourth cases, when you just try to imagine with your ruler that you are touching the curve and drawing a tangent, the steepness of the tangent is getting less. This means that in the first two, acceleration increases, and in the second two, they are also accelerating, but acceleration decreases. But when velocity decreases with respect to time, decreases with respect to time, decreases with respect to time, the next four are all about deceleration. But deceleration can increase and can decrease. Hold your ruler. Imagine that you're drawing a tangent. It is very steep. Yes, it's negative. Negative gradient, yes. It's negative because deceleration. But it's becoming less steepness. So first and second, they are the same case. Deceleration decreases. But in this case, when you start, the gradient is almost zero. And then it's getting steeper, steeper, steeper. In the third and fourth. So in the third and fourth, yes, it is deceleration, but deceleration increases. And in the first and second, yes, it is deceleration because velocity decreases with respect to time, but deceleration here decreases because the steepness decreases. This is just an introduction, and take care about units of measuring. If units of measuring of velocity is meter per second, and then you are dividing by time, which is second, So you will get the answer in meter per second square, or you can write it meter per second square like in index 1.